Okay, all right. This is a view of our remotely operated vehicle, the SuBastian. Now making some check for the white in order to have a very clear images later on of bottom life. Well, the two pilots on my right today for the beginning are Adam and Christy and Chris. Sorry. The science room here included the usual team. So Federica and Andrew that are just filing up all the information that we are getting from the substrate and from the related life. Paolo and Julie, the geochemist and PI of this adventure, and myself. We're basically at the foot of an escarpment here, indenting the margin. Actual depth is 1500 meter, roughly. And our aim is just to get up to 600 meter. So again, good morning everybody. It's about 8:45 of Western Australia. We are now on the bottom in the western branch of the Bremer Canyon. We are continuing our exploration using the ROV SuBastian on board this vessel Falcor from the Schmidt Ocean Institute. And you are welcome to be with us. Ho ho, good fish is coming to greet you and us. And our main target are, again, cold water corals that should be actually living, that is our hope, our prediction, on the rocky wall that is the target, main target of our dive today. Let's be tuned. So there are a few fish around. We just cross over. Oh, you can see on your left rat tail, sort of an eel.
Any idea what those are? Little masses.
I don't know. Do you want us to get a closer view? Well, the two green spots are just the laser beam that we are using to have the dimensions, so they are 10 centimeters apart. So you have now an idea about the size of the item that you are showing on the screen. Well, it seems to be on a kind of worms. There are polychaetes, so marine worms everywhere, sitting in the sediment, but also swimming in the water column. So the way we are actually recording what we are seeing is basically through very simple descriptors. Some are just, okay, explain that, for instance, now we are getting to the foot of a rocky wall. We will see a number of different organisms. We are not now going to put any special detail on most of them. Later, specialists in the different groups for fish, crustacean, mollusk, you name, will go through these images and provide their classification. There is really a sharp contact between the rocky wall and the muddy plain at the foot. And now we started to see some coral attached to the wall. It seems like this time the wall is indurated, maybe like hard ground situation. So we have seen what we think is a black coral with a brittle star on, sponges, a worm. But today, actually, basically our main target is a coral called Desmophyllum. If we found him, we will be very happy, actually, especially the geochemists. You know. Yeah, there are a lot of tiny worms with a calcareous tube attached to the rock. This is rather a common form of life on most escarpment around the world. Solitary coral on your left. We have a bamboo coral. It's a pretty animal. Actually, bamboo corals are important to us because we are using the skeleton to understand some important attributes of the water column that is coded inside their calcite. Wow, that's interesting. A lot of life here. Shrimp shrimp and sea urchin.
Hello, Mom. I just want to acknowledge that you're on, paying attention to what we do. Thank you very much. Love you. Bye.
Well, this is interesting anemone. And we had then the purple spots has to be tiny sponges. Actually, the nature of the substrate here is very promising. It looks quite indurated, so good for the settlement of corals. We will see. Okay, Andrew, the biologist saying that is a deep sea darty. We accept this. Actually, he's doing the same thing we are doing, so he's exploring the cliff, probably for different purposes. We look for corals. He's probably looking for prey. So we see different kinds of autocorals. They are very beautiful, but actually they are not our main target today. So we can only admire them. We cannot spend too much time in closer observation. Sorry about that. Yeah, there's an interesting congregation of sponges and anemones, brittle stars. Well, there's a request by Jeremy to sample one of those whip corals. Well, actually, whether possible, we'll do that. Not sure that we can do now, but remember that is the second dive of a very long cruise, so we will have a chance. Today our priority it will be just cap corals and specific species. But be optimistic, Jeremy. So we are now evaluating this cap coral. A little bit small for our purposes, but we don't even know if it's one of those we want.
We could see if we can disturb it.
Right, there was some discussion here in the science room about the option to collect one of these cap corals. So we will try. It's not obviously simple, considering that this is small and on a hanging wall, but now we will try. So the next few minutes will be spent here.
Okay, I'm going to.
There are many options to try to sample items here. Now, in consideration the small size and vertical position, we are trying to suck the specimen. It's not easy. Geologically speaking, this margin here is quite interesting. There's a clear-cut escarpment striking west-southwest along the entire Western Australian margin here. So it's a major feature. The topography is complicated by multiple incision in different direction. In fact, very soon we will get into one such indentation. It's a deep subsidiary.
It's not any of it.
Yeah, sorry whether to interrupt our conversation because of a technical problem. It was very noisy, so we have to fix it. Okay, it's not an easy operation to sample a coral sitting on a vertical wall. Now you know. Good news, that is exactly one of the kind of corals we want to sample. So they are around as we expect. Wow, okay. So Adam, the pilot, is saying that we collected is now is safe in a jar. Great news. Bravo to the ROV pilots. So now we are trying to collect also the second one. There are probably many such corals at this depth on this wall. And basically these are the very first samples that are actually useful for the core of the present mission. So as you can imagine, there is some excitement among the geochemists. And it's Julie Trotter, that is from the Western Australian University in Perth, Malcolm McCulloch from the same university, and Paolo Montagna from the Institute of Marine Science. Actually, no longer now is Institute of Polar Science, the new institute that we made in Italy. And they will spend some times later ashore to discover all the secrets that are sealed within the aragonite, so the mineral part of this coral. Well, everybody's clapping here to the ability of our pilot to catch what we need. Now these two corals will travel with us for a few hours, and then we will be placed in an aquarium, in a tank on board the ship. Actually, where we are replicating the condition here in the sea bottom. We must remember that we are deep in the ocean, and the water temperature here is quite low, about 6 degrees.
No, 3 degrees.
Actually, 3 degrees. Yeah, 3 degrees. Yeah, yes, okay. Wow. Almost freezing. It could be worse. It could be worse. When you've been to Antarctica, actually the water temperature was almost minus 2 degrees. Not very pleasant, isn't it? Okay, that is what we call a good start for the day. Now we resume exploration. One of our candidates is now safe in one of the boxes, but remember that our main target is another cap coral whose name is Desmophyllum. Let's see if the day will be generous to us. So we have a question from one of you observers ashore about the potentiality of our sucker to sample small fish. And the answer is yes, provided that that fish is accommodating, so it's not really too quick to swim away, as most fish normally do. So basically, yes, practically, it really depends. Okay, as you can see, now life is a little bit more scattered on this part of the escarpment, probably because the current strength is not that strong here. Judging from the draping by mud, this could be an argument to think that there's circulation here, currents are more sluggish. But of course it depends place by place. Okay, not all form of lives really like to sit on rocks, as we know. So there's brittle start and the coral, they prefer to enjoy life on mud. It's good for us, so we have many things to observe, independent from the kind of substrate. But basically, we will discuss this interesting aspect on our blog. So again, if somebody feel interested in having some detail later on, maybe we can find some simple conversation, opinion reported in our blog. Okay, we see another coral that we want to check for. Technically, this kind of corals are called solitary corals. I think that you may have an idea why. Not basically, it's not because they stay by themselves, but because they are just single polyps. Other are colonial. Even solitary corals quite often are gregarious, so they stay by hundreds in the same spot. Again, we are considering maybe, well, first we approach and we look at the specimen, and then possibly we are going to collect. So there is an observation by one of you observers ashore. Of course, those corals, yeah, they are not like those that are living in the photic, illuminated part of the ocean, so they don't really need zooxanthellae, photosynthetic symbionts. In fact, one way to call these deep water or cold water corals is exoxanthellate corals. Okay, now we succeed in getting our third coral, and we will resume exploration uphill. Remember that our first target will be Desmophyllum. Well, so that is where the jars where we are preserving some of the more delicate samples. Of course, we have also containers for heavy rocks or big stuff. As for example, what we collected during our first dive 2 days ago, we really needed to put in big boxes. And yeah, I can see some of the comments that, well, cap corals are pretty. I agree, they are really pretty. Yeah, yeah. Jeremy is pointing out that still new species, even the sclerotinas or the stony corals, are going to be described these days. Yeah, we know that. Actually, we should remember that the deep ocean is one of the most unknown part of our planet. And discoveries are easy to be done, but you need, of course, a technological help for that. And also the advancement of science now is helping in discovery species that are cryptic. You can only understand that they are different from cousins based on their genetic fingerprint. Okay, we spent some time here. We have to make some technical check on our equipment, and now back to exploration. Yeah, it's always interesting draping by mud that is not exactly something useful for us. Is actually providing habitat to other species. So there is this overhang, some small terraces where mud is present, and this is a good site for from some worms and some brittle stars, as those that we've seen on the muddy plain just below. So while we are proceeding, we are continuously filing up data, and that means that we have a video, we have stills, and we have a description of the sediment type, the substrate, and the animal life. Then all this information will be combined later in what we call habitat mapping. So just map where everything is categorized and the exact position of the sea bottom is marked. It's very useful, for instance, when you are thinking about design plans for protecting an environment. You have to provide quantitative data and information on relevant form of life. Sometimes we will see us stopping just to approach closer things that we don't know if they are dead corals or not. This one was obviously was not, but we need both actually living and dead and subfossil corals, because once again we are using these corals as information, climatic and oceanographic information sealed in the skeletons, and if we have fossil ones and modern ones, then we can have a vision through time about the oceanographic attribute of the water column here, that in turn means that we can recognize major or minor modification of the water column that are climatically meaningful, like temperature, salinity, nutrients, response to ocean acidification, etc. So there is a general question, what are we looking for? Okay, first of all, we are the first to explore using an ROV this sector of the Western Australian margin. So whatever we, that means you and us are seeing, is the first time ever for a human eye. So this is basically exploration. But then that is not enough to justify such a mission. So we have a clear, precise target. Again, as climate, as a climatic target. We are using stony corals like archives of climatic information. We are not doing this exercise only here. Basically, this is a global initiative, and are now decades that scientists are collecting similar corals anywhere in the ocean, and they all contribute to the big picture. A couple of pretty sea stars. So once again we have a deep water doryfish. That is the diagnosis by Andrew Ozzie from the Western Australian Museum. Albeit is a specialist in crustacean. The wall here is indurated, and the black patina in all likeness is due to the precipitation of iron manganese oxide. Again, is a very common view on many deep sea sites around the world. For us, is an indication that is a hard substrate that is suitable for animal life to comfortably settle on the wall. There are many serpulids that are a kind of sort of marine worms, and of course is a good also substrate for the cap corals we are looking for. Yeah, the purple animal is a crustacean, is an isopod, and then we see that there are whip-like corals alive, but also some stumps. So the dead base of once alive corals. They project in the water column, and then they are filtering seawater for their nutritional needs. You should remember they are quite passive, so they really rely upon the fact that some nutrients are bringing to them by currents or falling from the upper layers. There is no escape, they cannot move. That's interesting. They seem to colonize the overhang. Possibly this is a way not to be dripped by mud, still keeping well within the water column.
There's a coral there.
Yeah, okay, we stop now 1 second to have a closer look. Okay, there are sponges, a cnidarian, and maybe some coral. So now we approach and we explore. Well, that's good news. Apparently, this is a branch of colonial corals. They could be Solenosmilia or allied species. We will see on board. They are dead, but this is okay for us because we are also looking, as I say before, to subfossil material, and there is always a reason why they are alive or not. And sometimes it's just a climatic oceanographic argument. So we are about happy in collecting or trying to collect a sample now. Some 5 years ago, we were in the Perth Canyon to make a similar study, and in fact, over there we found both live and glacial age such corals. So we are put in a single story now. So that's it. Yeah. So we will stop here for a while. Now we have to choose what we do. Just watch.
Yeah, at least
Well,
two or three.
I think that we just spot our main target. We have the colonial coral and apparently desmophyllum. So the cap coral that is our best candidate. Some seem alive, some are dead. The desmophyllum are the cap corals that are partially, covered by the sponge. There seems to be alive, seems to see the polyp expanding in the water column. Well, so in the first half, 1.5 hour, we probably met our main targets for the cruise. In the meantime, now we are thinking about the best sample strategy. We see brachiopods for the first time during this cruise. Now, the second team of ROV pilots is sitting next to us. This is Jason Ekodi. So while following the operation to try sampling the desmophyllum, yeah, I can read observation by observers ashore. Well, about putting names, that will be something that will be done later by specialists. It's not very easy to classify everything, by simply observing the animal on the substratum or in the water column. One cannot be specialist of everything, so margins are high that you can just, give a wrong name. So, like for the acorn worm, we don't have a name yet, and this possibly is for most of the animals, fish, worms, cnidarians that we are watching. We feel a little bit more confident, of course, with our cap corals, and wow, we just get the first desmophyllum for this expedition. Is going to provide important information on the status of the ocean. Again, we should remember one thing, that we have 100 of this desmophyllum taking through time at different locations in the world ocean, in the Pacific Ocean, in the Atlantic Ocean, the Mediterranean Sea, and they will all be plotted one day in a single picture encompassing the history of and the story actually of change in currents and the properties of the ocean masses through time. And this is very important also to predict some level what is possibly expecting the ocean in the future. And it is important to have also information from these dead corals, because as often the geologists say, the past is key to the present. And in our case, we hope that it's key to the future. Well, we succeed in getting our first desmophyllum. Now we are considering taking one brachiopod, that is this kind of bivalve animal, actually attached to the wall. Brachiopods, they have a shell like bivalves, but they belong to a totally different group. Very old one. They are inhabitants of our planet since the Paleozoic and possibly earlier. We're also seeing a fossil, or actually dead, desmophyllum, and very likely we will try to sample also that specimen. And lastly, we will probably go for the Colonial dead coral. It could sound a little bit technical, but it is important to collect different kind of animals from the same spot, especially those that have a shell, because the shell is basically calcium carbonate, so it's what the geochemists here are looking at. But there are different kinds of calcium carbonate. For example, the corals, their shell, their skeleton is made up by aragonite, while the brachiopods, they are calcitic. So it is interesting to see and to check maybe the signal, the water signal, as recorded by animals that are different in their composition. All right, now we have another passenger on board the ROV traveling with us. Yeah, okay. Welcome on board. Almost.
We got a traffic jam.
So we are to decide the strategy case by case. We have seen that is a dead cap coral, probably a Desmophyllum. We like to get that specimen, but also the colonial dead coral. So we are considering who is going to be sampled first. These dead corals are they can be dated. It would be very important also to know exactly when they die, and it would be easy either using the common method called by radiocarbon, so the carbon 14, or even better for corals because they are aragonitic to use a method that is called uranium thorium, that is based on the fact that they incorporate substantial uranium during their life to be measured later on and to get actually a precise age. All right, so we have 100% sampling success so far. I tell you, that is completely remarkable. So we are very pleased. There is a lot of enthusiasm here in the science room. Now we have to try to get the colony that will be a little bit friable. So we'll see. We'll see how things will go.
This is going into a biobox. Yes. I'm going to give this a
We have done a first attempt to collect the sample with the robotic arm, but now we are considering that perhaps it's not a good idea, so maybe we go back with the sucker, because we only actually need a small branch, we don't need the entire thing. For those who started to follow us now, a couple of hours ago we start a new dive off the southwestern margin of Australia in the Bremer Canyon. We are about 1400-meter water depth. We were exploring an escarpment here, hoping to collect some corals. Our hope turned to be very been fulfilled by what we found in the last hour or so. We were looking for cap corals and colonial corals, stony corals, for our geochemical needs, to set some paleoceanographic history of the ocean here. And our main candidates were Desmophyllum, a cap coral, and Solenosmilia, a colonial coral, dead and alive, wanted dead or alive. And in this specific spot, in this overhang, we collect example of both. So we are very, very happy, because that's the second dive of a long cruise, and we already started to get and found and collect what we were looking for. When they are alive, these corals, they don't have this brownish hue. That is typical of long dead corals, because they got the same patina as the bedrock because of precipitation of iron manganese oxides that is commonplace in the deep ocean, almost anywhere. So since we have still only less than 3 hours to go before calling off this dive, we are now trying to be fast in rising up to a shallower depth, with the aim to maybe to find corals intercepting water masses with different characteristics with respect to the one at 1300-meter water depth. These are
Anything of interest? No. Keep going?
yeah. Ah. Maybe the same fish that we saw before. Actually, we should be an attraction, for animal life here. We should always remember that, in spite of what we are seeing now, this world is in complete darkness since ever, and it will be in complete darkness again after our short visit. So not surprisingly, some of the fish and the squid sometimes are coming to check for us. So maybe they have stories to tell back to their families later on. Ah, look at that. Okay, there is again one question about success in actually using the suction gear to collect small fish. The ROV pilots say that is in principle possible, provided that the fish is somehow collaborative. That means that is not, flying away. well, we spot this large bivalve. It might be one sort of clam that we call a chesta, so file clam. They are not uncommon at depth in the world ocean. They have a long geological history. We know actually shells like this since the Miocene epoch, so we're talking about some 20 million years ago, and maybe even older than this age. They also grow by secreting distinct increment bands, and this is what normally geochemists like us are looking for, because then you can start changing the water column at maybe the scale of years, not necessarily centuries or millennia. So now we may try to collect this, but it will be difficult because it's just in a very steep position and there is an apron of sediment and so on. So now again, decision will be up on the ROV pilots on how to proceed. Okay, now apparently the decision is taken. We are now using a different device. It's a scoop So we will try to collect the sediment containing the big shell, and also eventually those branches, dead branches of maybe corals, we don't know yet, that are actually emerging from the sediment. It's not easy, but we cannot use the suction gear in this specific case. And the robotic arm may really break the fragile shell. I'm happy that you can see at work so many different devices and see how you should adapt to situation. Never there is 100% let's say success. Although so far yes, but we are always ready to actually to minor failure. We do our best.
We've used a big one.
For meteorites.
Yeah, it was ridiculous.
Let's say.
Meteorites.
We don't know that yet.
Well, the scope didn't prove useful to collect that specific sample. We may have another try with the robotic arm. Otherwise, we will keep going upslope to explore for other cold water corals.
Are you stable? Pretty stable right here.
Now we can confirm that is a cesta. We can see perfectly the shape of this file clam. And also now we know the nature of most of these branches that are just autocorals that we call Isididae.
Right.
Yeah, it proved very difficult to collect the shell, but in the meantime, by stirring the sediment, something maybe also very interesting for the geochemical story appear. These branches here, some obviously belong to a bamboo coral, and bamboo coral is a good candidate for paleoceanography, and they are much more solid than the thin paper-like valve or the big shell. We will find more, possibly, hopefully, in the next days. So at least we grab the bamboo coral, a dead one, to put in the box. Well, probably just 1 hour, maybe less. All right. So maybe we have time for a quick exploration. Our corals, just to get a picture out of it. Well, that is an interesting animal. Is a sea spider. So pycnogonid is an arthropod. I think it's the first that we have seen so far. And this is a big specimen. Actually, most members in these groups are small. Exceptions are to be found in Antarctica, where they are really giant. Another overhang, and steamed by life. So eventually they like to hang down. So in such a way they avoid to be draped by sediment. So to be over-silted, that is not a good idea if you cannot move from where you are for all your life. We're moving fast upslope. So these are basically the same soft coral I've seen so far. The Brito star we already seen. There is another a chesta valve on the sediment. So the implication is that probably there are be living ones attached to the substrate that may be higher on this slope. So we will have other option to sample
There's a lot of dead coral.
some shells.
No, it's okay.
I got a lot of dead coral coming up. I'll just get rid of
Right.
the thing coming up.
Wow. Yeah. Another sea spider.
Just
Collect it now.
if you won't know.
Maybe now.
Yeah.
Yeah,
Let's go.
There's a lot of bamboos. I
Okay.
think
Yeah. An interesting spot, and no doubt. All the bedrock look dark, black. That's not necessarily the real color. Again, when the rocks are exposed to seawater, quite often they are coated by a patina of oxides. Those that we collect 2 days ago in at 1,000-meter water depth, they were not really strongly coated by this iron manganese patina. We could understand better their nature, and basically at the end we collect three types. Two are old sedimentary rocks, probably predating nice sea star, probably predating the split away of the Gondwana continent, so Australia and Antarctica actually separating. That was taking place 80 million, starting maybe in 80 million years ago, and completing the separation by 30 million or so years ago. And then we collect the third type was the whitish, friable limestone, the chalky limestone, that is in fact documenting a different time after the separation, after the splitting of the two continents, when a marine stretch interposed between Antarctica and Australia, then becoming the ocean that is separating the two continents right now. So once again, we are scouting quickly of light. No doubt. So now we have to take the perfect coordinate because that is really amazing, absolutely amazing. Wonderful stuff, wonderful. But weather is not that good and will deteriorate a little bit, so we don't really want to put at risk, you know, our expedition, our machine. The ROV is a delicate gear, get up to the surface, to the deck.
Anyway, it's full of
Yeah. Very happy that we could share for the first time. So if you want to have a safe life, organisms like those coral and brachiopod and bivalves, then better you get a shelter. What better than having a roof